Greetings, pre-calculus students, to another lesson in our class. For today's video, we will be talking about a little bit about that Desmos exploration that you guys tried earlier in the week regarding being able to identify points on a circle that our friend Paul walked around a circle as Olivia watched him. And we're going to start out by looking at number 2E really quickly, because this is going to tie into the new concept that I hinted upon earlier that we will be covering, which is this idea of a radian and what is a radian. So we're going to look at 2E really quickly because that's going to preview what a radian actually is. So at 2E, it asked us to determine where would Paul end up on the circle if he walked approximately 1 meter. Okay, so where would Paul be in the circle if he walked approximately 1 meter? So one way to think about it, and this was kind of a hint that I was trying to get at in class as well, was this idea of trying to cut the circle into sections. We know that the entire distance around the circle, okay, so we know the entire distance around the circle is just the circumference, which is easily calculated as being just 2 pi. Or, if we write it as a decimal, 6.28. From there, we can just cut our circle into sections to get an approximation of where 1 meter would be. If the entire circle is 6.28, well, half the circle would be half of 6.28. So half the circle would be 6.28 divided by 2, which is about 3.14, or in other words, pi. So that's half the circle. Well, what about a quarter of a circle? Well, a quarter of a circle would be half of that. So a quarter of a circle would be half of 3.14, so about 1.57, or half of pi. Right? So that's a quarter of a circle. Well, if a quarter of a circle is about 1.57, that should give you, or that should help in determining where this 1 meter is. So that means 1 meter is going to be approximately, we're not going to get an exact answer now, but 1 meter is going to be probably, maybe somewhere around here. That's going to be our 1 meter. And once again, it's going to be somewhere in that region. It's impossible to get an exact calculation, but that's going to be around where that 1 meter distance is for Paul when traveling around this circle. Okay, so once again, just to recap, full circle is about 6.28 or 2 pi. Half a circle would be half that, so about 3.14 or 1 pi. A quarter of a circle would be half that, so about 1.57 or just half a pi. So that means 1 meter would have to be somewhere before that, right? Because 1 meter is less than 1.57. Well, now let's get into this idea of what's the significance of this 1 meter distance. So let me go through here. So the distance that Paul covered in 2E, that 1 meter, corresponds to what is called a radian. So if I were to just quickly redraw this circle, all right, and make that the axes. So we said it was around there. So what do we mean by it corresponds to that distance? Well, first thing to remember, a radian, sorry that my drawing kind of overlapped that, but a radian is a unit of measuring angles, right? Up to this point, you've always measured angles using degrees, right? So 57 degrees, 60 degrees, 70 degrees, so on and so forth. A radian is another type of unit that we can use to measure how big an angle is. So in this case, well, what angle are we talking about here? And this is kind of hinted upon in number 4 in your Desmos exploration, but the angle that we're talking about is the following. is the angle that intersects that distance, that arc. Remember, an arc is just a part of the circumference of the entire circle. So the angle that we're looking at are the two lines coming out from the center of the circle that intersects that part of the circle, okay? So that slice of the circle. So that's the angle that we're talking about. And that angle right there that has a distance of 1 meter, that angle right there is 1 radian. That angle right there is 1 radian. So it's a unit for measuring angles, okay? So it's a unit for measuring angles that corresponds to the angle that intersects the arc. Actually, got to be a little bit more specific here because we give a special name to the angle that comes from the center of the circle. We call it a central angle. That intersects the arc of measure 1 radius. Okay? So it is an angle coming from the center of a circle. So it's an angle coming from the center of the circle that intersects the arc, okay, the arc on the circle that is of 1 radius long. So what do I mean that the measure of it is 1 radius? Well, if you recall, if I go back here, way back in the intro to the problem, right, this is the original circle that's given in this problem. And if you recall, since Olivia stands at the origin and Paul stands at the point 1, 0, that means that the distance between them at the beginning, or actually throughout, not only at the beginning, the distance between them is always 1 meter. Or in other words, the radius is always 1 meter, because remember, the radius is the distance from the center to the edge. Distance from the center to the edge. So since our arc is exactly 1 meter long, well, that corresponds to the radius. So it's important to make that distinction, this idea that it's always the length of 1 radius, because of the fact that radians can be applied to any circle. Not only the circle that you worked with in the Desmos exploration, but to any circle. So whether the circle has a radius of 1 meter, whether the circle has a radius of 10 meters, 1 radian is always going to represent the same angle. Okay, 1 radian is always going to represent the same angle, okay, because obviously if we change the radius, even though the arc gets bigger, it's the same slice of that circle, if that makes sense. So hence it's the same angle. Okay, so once again, it is the central angle, so the angle coming from the center, that intersects the arc of measure 1 radius. Okay, so the arc that's intersected by that angle is exactly however long the radius is. In this case, it's 1 meter, but if it was a different type of circle, it would be that many units of length. Okay? So arc length of 1 radius. Oh, sorry about that. So I just really want to emphasize this. So that angle is 1 radian. Okay, so that angle is 1 radian. We would say the measure of that angle is 1 radian. So that is what a radian is. Well, that is what 1 radian is. So here's hopefully a GIF that better illustrates, if I didn't explain it well in the previous slide, of exactly what a radian is. So let me restart it actually. So here we have a circle. Okay, here we have a circle, as you can see. And obviously the radius is just the distance from the center to the edge. And here we take the radius, Okay, we take the radius and we make that the length around the circle. You see how that red line just curved? And once again, that green angle is 1 radian because it corresponds to that arc. So then we have 2 radians, 3 radians, 3.14 radians, which is pi. Okay, so pi radians is half a circle. Pi radians is half a circle. And then the full circle is 2 pi radians. Okay? So I think, does it not? Oh, I thought it repeated there for a second. Okay, so just to recap, once again, we have the circle. Okay, we draw the circle. The circle has a radius, whatever it may be, and our circle is 1 meter, but it could be anything. We take that radius, we put it on the circle, so we curve the line, in other words. So that angle that's created from that radius is 1 radian long. Okay, then if we keep on going, 2 radians, 3 radians, and then 3.14 radians, which happens to be pi radians, which is that half a circle. Okay, so the angle that creates half a circle, if that makes sense, the angle that creates half a circle is pi radians long. And then for a full circle, it's 2 pi radians. So we use radians when we talk about this idea of circles because of the fact that we're talking about this, like this circular rotation, if that makes sense. So typically when we discuss this idea of radians, typically they're done in the context of circles, though they could be done in the context of other situations as long as you have some kind of angle. Typically we're talking about circles because of the fact that it's this idea of rotating around, just like Olivia did in the problem. So now let's talk about number 4. So number 4 talked about this, referenced this idea that I think it was Olivia that made this conclusion that if she turned pi over 2 meters, that was the same thing as 90 degrees. And the reason why that happens is, if you recall, we talked about this earlier when we were going over number 2, is if I redraw this circle here, right? And we talked about earlier that the full circle is 6.28, 2 pi. Half a circle is half of that. So half a circle is about 3.14. Or pi, well, half of that would be around 1.57 or half a pi. So you might be saying, all right, so once again, let's focus on the green part because that's the pi over 2 part of our example. If we look at the angle, so now let's look at the angle that's coming from the center. Remember, the angle comes from the center. The central angle to that arc, let me use green? No, orange. Yeah, orange. Well, the angle is going to be this one, right? That's the angle that intersects that arc because that's the angle that would create that slice of the circle. Well, if we look at the angle, right? If we look at the angle, so we have a line that's going straight up and we have a line that's going straight across. Well, if you recall from geometry, the angle that's created by 2 lines such as those is 90 degrees. So we end up with that 90-degree measure. So that's why, or that's basically the gist of number 4, what Olivia was observing of the fact that she saw that, sorry about that, she saw that if Paul traveled at pi over 2 meters, okay, so that green part, if Paul traveled at pi over 2 meters, that angle was 90 degrees because she literally turned from facing like to the east, if we want to call it that, to the east to facing north. So that's your 90 degrees. So as a result, we can make a conclusion here. If a quarter of a circle is 90 degrees, or if a quarter of a circle corresponds to a 90-degree central angle, oh no, I'm sorry, that was in the next slide. Then that means half a circle would be that 180 degrees, would correspond to that 180 degrees 180 degree central angle. And that's where we get our pi radians at the same time. Because in order to travel, in order to travel that half distance around the circle, that's how many radians we need. About 3.14, as we saw in the in that little GIF, right? It doesn't read. Oh, I have to do this. There you go. Just a quick reminder of why it's pi. All right, because if we take the radius and we curve it onto the circle, we get that distance with the angle of 1 radian. So that angle is 1 radian. And then the bigger angle is 2 radians. And then the even bigger angle is 3 radians. And then finally, to get that half a circle, we just need a little bit more. So it's about pi. It's exactly pi radians, or 3.14 radians. Okay, so let's try to use this relationship for some problems where we find, oh, I forgot to put the, I made a mistake on this example, but it's okay. So we're going to do 2 things with each of these measures. We're going to place it on a circle, and we're going to identify what the central angle would be that corresponds to this angle measurement. So 5 pi over 3 radians. So there's a couple of ways that I've usually had students approach this. Not the only way. And I saw some of you on the Desmos exploration do it a little bit differently. So if you did it completely different than this, then hey, if it works for you, go for it. You're fine. So one way to think about it is 5/3. Okay, so just ignore the pi. Just ignore the pi for now. 5/3 is the same thing as 1 2/3, right? It's 1 whole and 2/3 remaining. 1 2/3. So try to think of this as, so now we have that pi. So try to think of this as 1 pi and 2/3 pi. Okay, so 1 pi and 2/3 pi. Okay, so why is that helpful? Well, we just said in the previous slide that 1 pi corresponds to half a circle, right? 1 pi corresponds to half a circle. So we know we've gone this far so far because that's 1 pi, okay? So that's 1 pi. Well, so now the question is, well, how much is this 2/3 pi? How much is this 2/3 pi? Well, here's one strategy that I've seen work for some students is how do I determine how much that 2/3 is? Is to try to slice your circle. Try to slice your circle, well, your half circle into thirds. Since we've already done half the circle, okay, so now we still have a remaining half left. We're going to slice the remaining half into thirds. So we'll use the green part now. So once again, this is going to be very approximate. So that's 1/3. That's 2/3. Okay, so the blue part is 1 pi. We're trying to figure out how much that 2 pi over 3 part is. Well, if 2/3, so we need 2/3. So this would be, this would be 1/3, right? Because it's one of the 3 slices, so 1/3. So this would be 2/3. Okay, so it looks like that 2/3 slice would be somewhere around there. Just to highlight it a little bit better. Would be somewhere around here. Okay? So that is where we would be on the circle. Okay? That would be our final destination, if you want to call it that. So final destination. On the other hand, sorry about that distraction. On the other hand, now we have to determine, well, what is the angle? So what is the angle? We determine where we are on our circle. Now we have to determine what the angle is. Well, once again, we know half a circle corresponds to a central angle of 180 degrees. Okay, so I'm actually going to draw another circle here so that we can see it a little bit better. Okay, so we know the half circle, so we know that angle is 180 degrees. Okay, and then we split the bottom half of our circle into 3 parts. Okay, so we split the bottom half of our circle into 3 parts. So we know the bottom half is also 180 degrees. We know the bottom half is also 180 degrees, but since we split it into thirds, now you have to think of the bottom half. Let me use a different color. Now we have to think of the bottom half as thirds of 180. So if we quickly do the math, what is 1/3 of 180? That would be about 60 degrees. So each of these slices would correspond to an angle of about 60 degrees. Okay, well, exactly 60 degrees, right? So if the entire half is 180, and if we sliced it into 3 equal parts, that means each central angle there would be 60 degrees. Well, remember where we ended up with? We ended up with here, right? We ended up with there. So that means if we tally up our total, we have 180 degrees. Then we have another 60 degrees. And then finally another 60 degrees. So that means our total is going to be 180 plus 60 plus 60. So that gives us our 300 degrees. So that is our entire... I'm going to use it in red now. That's going to be our entire angle there. Our central angle is 300 degrees. So it's bigger than 180. Okay, so it's bigger than 180. Okay? So let's do the next one. So 3 pi over 4. Let's do the next one, 3 pi over 4. So let's use the same strategy, except this time we just have 3 pi over 4, so our answer is not greater than 1, right? 3/4 is not greater than 1. 5/3 was greater than 1, so that's why it was easier if we split it up. If we split it up a little bit, excuse me. But 3/4 is not greater than 1, so this time around we don't have to worry about the 1 pi plus. It's just 3 pi over 4. So this time, okay. We just have to worry about the half circle. We just have to worry about half a circle since it's not greater than 1 pi this time around. So if we're just focusing on half a circle, and I apologize for my circle. This time around, we're going to split up our circle into fourths. So in part A, we split it up into thirds. Part B, we're going to split it up into fourths. So if we split it up into fourths, it's going to be there. So just think of like slicing a pizza, basically. I'm just slicing the top half of the pizza into 4 equal slices. So let's see. So this would be 1/4. This would be 2/4. So this right here is 3/4. So that is where we would end up with. Okay, we would end up at that point on the circle if our angle was 3 pi over 4. And this time around, since we split it up into fourths, because once again, remember, half a circle corresponds to a central angle of 180 degrees, this time around we're going to do 180 divided by 4. So that means each slice is a 45, for each angle is a 45-degree angle this time around. So we have 45, 45, 45, 45. So each of those angles is 45 degrees. Well, since it looks like we took up 3 of them, we're going to do 45 times 3, which gives us, or 45 plus 45 plus 45, which gives us that 135 degrees, right? So this one was not as bad, since we didn't have to do more than half a circle. We just did half a circle. So So this would be our angle this time. So that would be our 135 degree angle, that green slice of the angle. Okay. So there you go. That's just one strategy. I'll be honest, this strategy is not the quickest. It's a good intro strategy for determining where on your circle you'll end up with, determining based upon how many radians you have. But once again, I did see some of you do pretty well on the Desmos exploration with determining where on the circle you end up with. So for some of you, you might have thought about it differently, which is completely fine. Obviously, this whole connection with the central angles is completely new. But what I want you guys to do now is I want you to try this example 1C on your own, just as we've done previously with these lesson videos. I want you to try this example 1C on your own. So try to use, if you have your own strategy, go for it. If not, if you want to try slicing this circle up into pieces, in part A we did it into thirds, in part B we did it into fourths. So in part C we would do it into fifths. Give it a go. See if you can do it. Otherwise, let me know if you have any questions as usual. I hope this intro video into what a radian is was informative. But otherwise, I wish you guys an enjoyable rest of your days.